We will now determine this value of dx by dt using the given conditions as well as using this equation related by x and y. We know that both x and y are functions of time. So this equation is basically an implicit function of x and y, implicit function involving x and y, where x and y are functions of time. So we will differentiate or we will find the derivative just by derivating each terms one by one. So basically we are doing the implicit differentiation. So we are going to differentiate with respect to time. So I'm going to write down this expression as a d by dt of the complete expression, that is d by dt of 2x squared, and I can find the derivative for each of the term, that is d by dt of 3y squared minus 4 times of d by dt of xy. I factor out the constant using the constant multiple rule, and then I put the derivative for 36 as well, which is basically a constant. Now let's continue. So we are going to find the derivative of 2x squared with respect to time. We are differentiating with respect to time. So we have to apply the power rule as well as the chain rule. So first let me factor out all the constants using the constant multiple rule. I have a constant 2 over here. I have constant 3 over here. I already factored out the 4 out of this xy term. So let me write down these constants. So this becomes 2 times of d by dt of x squared plus 3 times of d by dt of y squared minus 4 times of d by dt of xy equals the derivative of the number, which is the constant, 36. Now let's find the derivative of each terms one by one. So first we have 2 times of derivative of x squared. We can use the power rule. Uh, Derivative of x raised to the power of n is nx power n minus 1. So I'm going to put the 2 in front and raise x to the power of 2 minus 1. So 2 minus 1 equal to 2, that is x raised to the power of 1, which in fact can be just written as x. And then I have to apply the chain rule because I'm differentiating with respect to time. So basically I do this d by dt after I apply the power rule. So d by dt of x is dx by dt. Plus we are done with the first term. Now let's move on to the next term. We have 3 times of, once again we have to apply the power rule to find the derivative of y squared. So when I do that I get 2y raised to the power of 2 minus 1, that is 1. So therefore it is once again y, and then I have to apply the chain rule to find the derivative of y alone. So derivative of y with respect to time is dy by dt minus 4 times of, here I'm going to apply the product rule of differentiation because we have the two terms as a product. So first let me consider this x, and then I find the derivative, that is d by dt of y, and then plus I keep the y as constant, and then I find the derivative of x. This is equal to, then the derivative of 36, which is a constant, is 0. So we are getting this. Now let's simplify this. So the first term is we have 2 times of 2x, which is 4x. So we have 4x dx over dt plus 3 times of 2y is 6y dy by dt, negative 4 times of, you can write down this expression as x times of dy by dt plus y times of dx by dt bracket equals 0. So again I'll just write down this clearly. This is dx over dt. Okay. Now we are done with this derivative. We can plug in this initial conditions and solve for dx over dt. So I'm going to plug in x equal to 2, y equal to -2, and dy by dt equals 4 into this equation. So I'm going to plug this. 4 times of x is 2, and multiplied with dx over dt, plus 6 times of y is -2, dy by dt, minus 4 times of x is 2. So therefore this becomes 2 dy by dt, plus y is -2. So I can write this as -2 times dx by dt. Let's simplify this. This is going to give us 8 times of dx over dt, minus 12 times of dy over, in fact, I could have substituted for dy by dt, which I did not. Let me do it now. So dy by dt, I'm going to substitute 4. So here it becomes 4. And once again, we have, I'm sorry for that, we have a dy by dt over here. So we can substitute 4 over here. So therefore, I can remove this. This is going to give us 6 times of -2 is -12. -12 times of 4 is -48. Minus, we have 4 times of 2 times of 4 is 8, minus 2 times of dx over dt. So now this equation involves all the numbers as well as only the one unknown, which is the dx over dt. So we have dx over dt over here as well as dx over dt over here. So we can simplify this and collect only the dx over dt on one side. So we have 8 dx over dt, and then here when I distribute this -4 with -2, I have positive 8 dx over dt. So I'm going to write down next to this 8 dx over dt. Now this is -48, and when we distribute this -4 times with 8, we'll be getting -48 plus 32, and this is equivalent to -16. I think just made a mistake over here. This is not positive 32, because when we multiply this -4 with positive 8, we get -32. So it is -32. So -32 -48 will be getting -80. So I'm going to replace this by -80 equals 0. Now let's add these two dx over dt. So 8 dx over dt plus 8 dx over dt will be 16 dx over dt, and I can add this 80 on both sides, so that I will be getting 80 on the right side. Now I divide both sides by 16, so I can solve dx by dt. So therefore this is going to be 80 by 16, and this results in 5. So we can finally see that the value of dx over dt equals 5. So this is the answer for this question.